I'm sure for many people watching along at home, WebAssembly is a technology that is on your radar, but not necessarily something that you've had to play around with yet. Our next speaker is hoping to bump that up our priority list. Taking to the stage, next up at the 2021 CityJS conference is TAMAS from London, UK. TAMAS is here representing Cloudinary today, and in this talk, TAMAS is going to be helping us supercharge our JavaScript applications thanks to WebAssembly. After you've watched this talk, please do join us for the Q&A session over in Gathertown, and keep your posts coming on social media using the hashtag CityJS2021, as well as the comments rolling in wherever you are watching along at home. TAMAS, it is with great honor that I hand the stage over to you.
Hello, everyone. It's good to have you all here. And I wanted to thank you, the organizers, as well, for inviting me to this conference. And I hope everyone had fun so far. So my name is Tamas, and I'm here to talk to you about supercharging your JavaScript with WebAssembly. And essentially, what we're going to take a look at as part of this talk is a couple of projects that I worked on and why I actually chose WebAssembly as a sort of weapon of or a tool in my projects. So I work at Cloudinary as a developer experience engineer. I have some other titles which I'm not going to go through. One thing that I would like to point out is that you can follow me on Twitter. So after this talk, if you have any questions that you didn't have the chance to ask, or you would like to have a discussion about WebAssembly or JavaScript or anything else, feel free to add me on Twitter, and my DMs are open. So let's take a look at the web platform as it was in 2018. Right, so think of this as a very simplified view of what you have inside your browser. So you have a set of web APIs, stuff like the Fetch API, for example, and then you also have a virtual machine as part of your browser, which is capable of executing JavaScript code, right? So you write some JavaScript and this virtual machine executes that for you, and that's pretty much it. And then this virtual machine and the JavaScript code execution engine can talk to the various web APIs that are inside the browser. So this is how the web or a browser or a web platform looked like back in 2018. Now, I think there's no denying the fact that the web today and in the past couple of years has been progressing at an incredible pace, right? We use JavaScript everywhere. We have libraries and frameworks that are heavily relying on JavaScript. In fact, I would argue that the main execution engine of a web application is now the browser itself, as opposed to the server that was the case, maybe 10 or 15 years ago. But of course, JavaScript has certain limits, right? It's not very good with things like CPU intensive calculations. It can't achieve very low level tasks because the browser has certain limits as well. Now, even if you can do something in JavaScript, something that's a very low level, it is very likely that you're going to be introducing some performance impact inside your application, right? So you're going to pay the performance penalty for using JavaScript for things that it was not intended to be used. And in light of this, we can talk about this thing called WebAssembly. So WebAssembly was created in 2015. And I have this little asterisk on the slide here because there was another thing which predates WebAssembly by 2 years. So in 2013, this thing, I think it was created by some researchers at Mozilla. They created ASM.js, which basically allowed you to take an application written in C and then run it as a web application, which is really the whole idea of what WebAssembly is trying to do. It tries to sort of port applications written in a lower level language like C, and then allow it to you to execute it on the web. So that is the essence of WebAssembly. And the good news is that as of 2019 and December 2019, to be more precise, WebAssembly is a W3C recommendation. It's part of the standard, it's part of the spec. So you have HTML, you have CSS, and then you have JavaScript, and now you have WebAssembly as well as a recommendation. So what is WebAssembly? So I took this description from the Mozilla Developer website or the Mozilla Developer Network, and they stated that WebAssembly is a low-level assembly-like language with a compact binary format that runs with a near-native performance and provides languages such as C, C++, and Rust with a compilation target so that they can run on the web. So that's a mouthful, right? So I came up with a much simpler explanation, which is sort of my way of explaining WebAssembly to people, and that is it allows you to run native apps on the web, right? It's very, very simple. It allows you to take applications that you wrote maybe 10, 15 years ago, even now, in a low-level language, and now you can access that and execute that and use that on the web via your browser. Now, what's great about WebAssembly as well is the fact that WebAssembly functions can be exposed to JavaScript. So you have a bunch of functions, a bunch of methods inside say a Go or a C++ project of yours. Those functions can be accessed by JavaScript in the context of your browser. And this is what gives WebAssembly really powerful options. So often I also hear that WebAssembly is going to replace JavaScript, or WebAssembly is the new JavaScript. I think that couldn't be further away from the truth, because I think WebAssembly is definitely not here to take over JavaScript, right? So it's not going to remove JavaScript from the ecosystem. It's here to enhance it. It's here to augment it. It's here to make it better. It's here to give it powers that JavaScript can't do. So it's a very good complementary language to JavaScript. So if we take a look at the same sort of figure that we saw in the beginning of this talk, which is the web platform and how it looks today, you have the web APIs and you have the virtual machine, but that virtual machine inside the browser is now capable of executing both your JavaScript code, and it's also able to execute WebAssembly code for you. And the great thing about this is because we're talking about the same sort of system, the same machine here, these things, all of these things can talk to one another, which also means that there is a WebAssembly JavaScript API. So this particular JavaScript API allows you to work with WebAssembly files, WebAssembly modules. We're going to take a look at the demo in just a moment, but it does have features like module loading. So you create a WebAssembly module, a WASM file, and then you can use the WebAssembly JavaScript API to load that module. And the loading of that module is going to be very similar to how you would load, an ES 2015 module using just standard JavaScript syntax. So how do you create a WebAssembly module? So what is the process of working with WebAssembly? And you have two options. Option number one is, you have code written in C or C++ or any other LLVM supported languages. So that's LLVM supported languages would be things like Haskell and some others, right? So there's a vast number of programming languages that you can use here. And then you use a tool called Mscripton, which is something that you would download. It gives you a CLI, it gives you a compiler, and you just specify your compilation target to be WebAssembly. So it basically transforms your C or C++ application and creates a WebAssembly module for you. And then you load and consume that WebAssembly module using JavaScript in your application in the browser. So that's one way. The other way is that there are other languages that directly compile to WebAssembly and can allow you to create these WebAssembly modules. So .NET languages, Java, Ruby, Go, they all can compile to WebAssembly. And then once you do that, you will again end up having a WebAssembly module file, which then you load and consume inside your browser. Now, if you're wondering, there's a large number of programming languages that support WebAssembly, and I think in the previous talk someone was talking about how Dino has a support for WebAssembly, which is true. So .NET, C, C++, C#, Java, Python, TypeScript via this thing called Assembly Script, they all can compile to WebAssembly. And someone has collected all the languages that have a compilation target to WebAssembly. You can visit this link to learn more about that. Okay, and now what I would like to do is show you a bunch of demos, and I'm going to show you 4 demos. Two of those are going to be very, very simple, just to show you the concept of how to work with JavaScript and WebAssembly together. And I'm going to show you another two projects, which are sort of real life projects that I created. And they have very interesting use cases as well, which I'm going to go through with you when we get to the demo. So let me change to my code editor here real quick. And we're going to start with a C example. Now, I deliberately kept these examples to be, simple, because I want you to understand the concept before I jump into the more complex example. So here we have a very simple C file, right, that has a method called inSquare, which accepts an integer as a parameter, and it returns a data type integer. And essentially what we do here, we just square the number. So we take that input and then we multiply it with itself. Before you tell me, I know that you can square and you can cube and you can do mathematical operations in JavaScript without any issues. The point here is not to show you how this is faster. The point is to show you how or what you need to do in order to create a WebAssembly module. So what I've done, I actually executed this command here that you see. So this is emcc, that's the mscripton compiler that takes our square.c file. I ask for a WebAssembly target. I'm exporting some extra runtime method like cwrap, and it will also create a square.js file for me. So if you execute this command, you're going to end up having two files at the end. You're going to have square.js, and you're also going to get your WebAssembly module, which is square.wasm. And then inside this index.html, what I do is I load that square.js file, and this JavaScript file is going to help me to load the WebAssembly module and access the methods from it. And then what I do, once the module gets loaded, I create this API object, and there's a million ways that you can do this. You don't need to follow this, but I just thought having an API object with an actual property would make sense. And then I assign this module.cwrap to that property. And in the cwrap, I'm specifying the C function that I want to call. And I always mix up this. It's either the first parameter is the argument or the data type for the argument that it accepts, and the second one is in this case, the third one is the return data type, or it's maybe the other way around. But what matters is that I can now access the inSquare function from my C file. I also have a button on this page, and then the rest is very simple JavaScript. So what I do, I add an event listener to that button. I have an input field as well. And then when someone presses that button, I'm just calling api.calculateSquare, and I pass in the input number, which is the value from my input field. So if I've done everything correctly, and I open this in my browser, what I should see is the input box, the button, and clicking that button, which we're going to do now. So I add 2, calculate, returns 4. So this calculation and the result is actually generated by the WebAssembly module. I'm not doing this calculation in JavaScript. Again, I do know that you can square numbers in JavaScript, but that's not the point here. Another way, so this is a C program, but I mentioned there are other ways to do this. And I have an example in Go. And again, this is going to be a very simple example just to demonstrate the concept for you. So in this case, we have a function called cube, and it's going to, guess what, cube the number. So it's not going to be super complex again. But what we do here, and I'm going to pause at line number 11 here, because I think if you're a JavaScript developer, you look at this and you're thinking, well, those things look very familiar. And you're right. So from your Go application, you can access the JavaScript DOM via the usual methods like document.getElementById, and then you get the what ID you're getting the result ID, and then you're going to set the inner HTML of this particular element with the result. Now, what is the result? The result is going to be the result of our calculation. And then what I do here in the main function in Go, I'm effectively telling Go that I want to export a function called cube. So I want to be able to access the cube function from JavaScript inside my browser. Okay, so that's pretty much it. Now, in order to get the WebAssembly module, I've executed the command that you see here. So I specified the compilation target of WebAssembly, go build, and then cube.wasm. And this has created a WebAssembly module file for me. Now, Go needs some different treatment with regards to how you load the actual WebAssembly module. The other thing that I had to do was to get this wasm_exec.js file, which I believe I got from the Go documentation or somewhere on GitHub. It's an official thing that they give you, and they say if you want to use our WebAssembly modules or WebAssembly modules created in Go, you need to have this WebAssembly execute.javascript file added to your page, because this essentially brings a Go runtime environment to the browser. So the way you would load this is you load the JavaScript, and then you instantiate your new Go runtime, and then using the built-in fetch API, you can just fetch the WebAssembly module, and then it's going to instantiate that, and you don't really need to do anything else here, because remember, we are accessing the DOM from our Go function. Furthermore, if you take a look at the calculation here, or the on-click handler for the button, it calls the cube function, right? So I'm pretty much exporting a function from Go, and I can access that inside my HTML or inside my JavaScript. So I'm calling cube, and I pass in the value that I gather from that input field. And when I hit calculate, notice I have this ID result here, which is just a paragraph. And then when I hit calculate, the cube function inside Go is going to be executed. And I set the result elements inner HTML to be the correct number. So if you take a look at this example, which is right here, of course, we're going to get a cube number. Okay, so again, nothing special, but now hopefully you understand these two ways that you can create WebAssembly modules. And of course, different languages, like .NET languages, etc., they may have yet another way on how to create WebAssembly modules and how to load those WebAssembly modules to your browser. So do research that and do take a look at your options for the language of your choice. So let's take a look at some more advanced examples, and we're going to start with this one, which is a tool that I've wrote using Go. And I need to give you a history behind this, because I really enjoyed working on this particular project. So let me open up a new tab here real quick. So I did mention in the beginning of this talk, and there's a reason why you see this lady, of course. So I did mention I work for a company called Cloudinary. For those of you not familiar with Cloudinary, it's a cloud-based media solution where you can upload images and videos to Cloudinary. They do the storage, optimization, transformation, and then the delivery of these assets via a global CDN. So I have uploaded this image to Cloudinary, and if I open my network panel, we can see that this is, of course, going to be a JPEG, just as expected. We can take a look at the content type, so that's image JPEG, and this image is 583 kilobytes in size. Now, what Cloudinary allows us to do is to modify this image on the fly by changing the access URL. So for example, I could add f_auto. So this is short for automatic formatting, which is then going to take a look at the browser. Cloudinary is going to take a look at our browser and is going to see that we are using Google Chrome, and it knows that the WebP image format is the best image format that we can serve for the Chrome browser. So it's going to automatically generate that on the server side and serve that image off for us, even though the extension is still going to be JPEG. And the result of that is that the size of the image goes from 583 kilobytes to 49 kilobytes. And this is just because we are using a different content type. And the beauty of this is that should I take this URL and open it in a browser that does not support WebP, for example, Safari? In Safari, this image is going to be a JPEG 2000 because that's the most optimal image format for the browser. And there's additional things that we do, right? So for example, QAuto is another thing that we can do. This is going to reduce the quality of the image in a way that is not visible to the human eye, right? So it's going to reduce the quality, but as humans, we won't be able to see the differences. But we do see the difference in the size because we went down from 49 to 32 kilobytes. So why am I showing this to you? The reason why I'm showing this to you is because I wanted to get more information, or I wanted to see more information about the image that Cloudinary loads. So I didn't just want to see that, hey, this is a WebP and it's great. I wanted to know more information about the WebP. So if you work with image encoders and other stuff, then you may have heard about the WebP containers. There are two types of containers. They contain information like alpha channels. If it's a PNG, if we render a PNG, I wanted to know more information about the PNG image itself. Now, can I do that in JavaScript? Some bits, maybe, but not everything. So what I did, I created this, not this one. Where did it go? I created this project, and this is a much larger and much complex application, which basically requests the image from Cloudinary, and then based on whether that's a JPEG, a PNG, or a WebP, it's going to do some additional analysis of the image. So for example, let's open the PNG check file, and you see that I'm directly reading, buffers, and PNG has a very good, specification. So I know that the first couple of bytes is going to define that this is a PNG. There's going to be information about the width and height, bit depth, color type, compression method used, and other things in the buffer that I can process using Go. So this is exactly what I do here, and I'm not going to go through all the code here because this is quite quite a bit of set of functions. And I do the same for WebP. So I check for the alpha channel, I check for the container type. So you see that I'm doing a lot of low-level work, which is, as I said, some of it may have been possible using JavaScript, but there's some that just doesn't exist in JavaScript today, that I can't access buffers and I can't analyze it against WebP containers, for example. And then I built a very nice user interface for this particular tool as well, and this is how it looks like. Now, here's a pro tip for you. We all know that you can't change the user agent, but I found a way that you can change it using the DevTools, which I'm going to show you in just a moment. So here we have the access URL for our image, and we're going to request this image as a Chrome browser. So if I hit check, there's no alteration in the URL. We get a JPEG, here's the size, here's the quality. That's great. But now let's see what happens if I add f_auto to this and I make the request as Google Chrome. This time around, I get a WebP image back, but I now can process that information and learn much more about my image. So this particular image is a VP8 WebP, so it has a VP8 container. It's lossy and it doesn't have an alpha channel. Now let's change our browser. So I'm going to go into this secret place in DevTools. So you click More Tools and you click Network Conditions, and then that allows you to select a different user agent. So notice that my application immediately picked it up. So now we're going to request the same image using Safari. And this time around, I can tell that it's not only a JPEG, but it's a JPEG 2000, right? Which is the most optimal format for Safari. And then you can play around with this. Let's take a look at another example where, and yes, I am asking for an image called darthdata.png. So I happen to know that this is, a PNG. It's, has an alpha channel. So let's take a look at what happens if I request this as Chrome. Okay, so I get a lot of additional information. So I'm not just saying this is a PNG, it's PNG 32. This is a size, it has bit depth of 8, true color with alpha. So it has an alpha channel, and the interlace method was, no interlace was used. And I can just play around and basically explore what happens if I change this to f_auto. Is this going to change from PNG to a WebP. So, 275 kilobytes. Okay, so it does change to a WebP, and actually it's a VP8X container this time around. It's lossy and it has an alpha channel, right? So you get the point. I can analyze all these images in a very convenient way, and it's very fast as well because I'm using WebAssembly to do all of this work. Now, the other project that I want to show you is a slightly different one. So a colleague of mine in 2017, and this is a guy's name, Jon, who's an image researcher at Cloudinary, he created this project called Simulacra, which is structural similarity unveiling local and compression related artifacts. So that's a mouthful, so let me simplify that for you. So what this C++ tool does, it basically compares the visual quality of two images, and it's going to return you a number. The closer that number is to 0, the more similar those images are in terms of their visual qualities, and the closer that number is to 1, then it's going to be really different. And what's great about this project is that when he was coming up with the algorithm for this particular project, he did actually utilize real user data as well. Right, so it's not just that we basically said, oh, this this image looks great, that doesn't, and then here's your algorithm. There was a very exhaustive, extensive user research done. We asked people, hey, here's an image, here's another one. Do you see a difference? No. Okay. Do you see a difference? Yes. So on and so forth. So the point of this is that this particular project was intended to be, just a C++ application that you would run on your command prompt. So you would say, you would generate an executable from this file, and then you would say, Simulacra, here's image number 1 as parameter 1, here's image number 2 as parameter 2. It runs on your machine, and it gives you a number back. So what I've done, and I'm pretty sure you can figure out what I've done here, I essentially took all this code. I had to change it, slightly here and there. And I don't know why I'm scrolling, because I'm not going to show all the code to you. But basically, what I've done is, after modifying this, and the modifications are actually on the top. I'm sorry, I scrolled down. I don't know why I've done that. Actually, that's not the not. I opened the wrong file. Sorry, this is the original file. So in the file that I transformed into a WebAssembly module, I had to do tiny little modifications. It took me about a day to do that. It wasn't like a big deal, but doing so, I could now take this project, which was never intended to be used on the web, to the web, because I created a WebAssembly module from it, right? And I'm going to show this to you now. So I have the WebAssembly module here. I created a sort of, similar styled application where you can read 2 images from Cloudinary, and then it's going to calculate the similarity between those. So the interface looks like this. And let me just show you these 2 images, right? So actually, you've seen this one before. So let me just copy this one as well. Notice I added a quality flag of 1. So this is going to reduce the quality to be, it looks like pixel art almost, right? It's not a very visually appealing image. So in this case, I expect this tool to give me a value that is close to, to 1. So it's 0.2. So that's definitely, not 0. What if I do Q10? That's going to be less pixely, but still not good. And if I do Q100, then of course these 2 images will be the same, so I would get a 0. Now, what is the point of doing this? The point of doing this is that Cloudinary has this Q auto flag, and okay, so there we go, 0. We have this Q auto flag, which, as I said earlier, automatically reduces the quality of the image in question. And I also said that it's not affecting the human eye. So I was thinking, well, can I actually prove that using the Simulacra tool? And if I calculate the similarity using QAuto, notice that we are very close to 0. It's 0.023 is our value, which is giving us confidence that these two images are the same for the users who are going to take a look at that. However, using the other tool, we could verify that we did introduce a lot of kilobytes in terms of saving bandwidth. Now, while I was working on this project, and I want to show you a bunch of things before I wrap things up. While I was working on this project, it was really interesting to learn a lot about how WebAssembly modules work and how the virtual machine in the browser works that is executing the WebAssembly code. And this is a prime example of that. So essentially what I do, and you're not reading that incorrectly, I'm actually writing files to the virtual machine's file system. So you can actually do that. There is this entire file system that WebAssembly allows you to use. And what I do, I basically download and save both of these images, run the simulacra calculation there, and I just send that information back to the browser. So it's really, really powerful that I can actually do this inside the browser purely because I have access to WebAssembly, and I can then do the calculation, which is, relatively CPU intensive because it does parse the image, it opens up the image, it's going to compare bytes, and it's going to do a lot of calculation. And even though there's a lot of work involved in that, the whole application executes really, really fast in a really convenient way inside my browser. So I'm not introducing a performance penalty anywhere. So if you're wondering, I'm going to give access to this to a GitHub repository towards the end of the talk. These two sort of real life projects, if you want to call it that, are not going to be part of that. I will add it at some point in time. I found one bug with the other project. That's why it's not part of that. But otherwise, I am going to make these tools available for those of you who are interested in just Simulacra, CPP. If you just Google for Simulacra, you should be able to find this. This is an open source project. It's available on GitHub. I think it's either under Jon's account or maybe the Cloudinary account. I can't remember. So you can find that. And then at a later point in time, I am also going to release this whole project because I think it's very valuable. Okay, so let me go back to my slides. So I'm going to leave you with a bunch of resources, and I hope I tickled your interest for WebAssembly. There's a link for Emscripten. It has very good documentation. The Emscripten compiler is very, very easy to set up. Once you do that, you can then essentially port any of your C or C++ applications to WebAssembly. And in fact, what I forgot to mention is the Simulacra project, that C++ file that you just saw. I use Emscripten to compile it to WebAssembly. And there were a lot of options that I set up, and there are some options that you can set up with Emscripten, such as how much memory you want your WebAssembly module to be allocated. Should it have access to that file system? All of these things you set up as flags when you do the compilation from C++ to WebAssembly. There's a sample repository. MDN has some good articles on WebAssembly as well. There's a bunch of interesting projects that I linked to here as well. So running Doom, someone actually ported the classic game from the 90s called Doom to WebAssembly, which then of course means you can now play and run Doom inside your browser, which is, I think, super cool. And speaking of super, someone also ported Super Mario to WebAssembly. Again, I'm linking to that. This is an entire NES simulator that someone created, which again, a very interesting thing that you can just port all these things to the web today. And of course, there's this flagship sort of application from Google, which you may have heard of, called Scrooge, which is accessible on scrooge.app. They do something similar with images. They do client-side processing of images and optimization of images. Again, that involves a lot of work because they are bringing in an entire WebP library and transformation module to the browser. And the only way they can do that is by using WebAssembly. And furthermore, they also created a case study. They compared the application using WebAssembly, and they wrote exactly the same stuff or very similar stuff in JavaScript, and now they're in this case study, they're comparing the performance of both of these, and you can take a look at that as well. I found that to be really, really exciting as well. So that's all what I had for you today. I hope you did enjoy this talk, and I do hope that you will go and try to maybe find an old project of yours, or have something in the back of your mind that you want to bring to the web using C, C++, or Go, and I hope that I gave you the encouragement to go and see what WebAssembly is capable of today. As I said, if you have any questions after this talk, or at any point in time in the future, feel free to ask away on Twitter. My DMs are open. I'll be more than happy to answer any questions that you may have about anything related to web or WebAssembly. I'm open to any questions. And with that, thank you very much for your attention.
Tamas, thank you very much for that brilliant talk on JavaScript and WebAssembly, and inspiring, I'm sure, a huge chunk of our audience to start tinkering with WebAssembly and incorporating it into their applications. I know I've been waiting for the perfect excuse to have a little play, and I'm sure many people at home have just found theirs thanks to your talk. If you are watching along at home and you enjoyed that talk, or even if you didn't, please do join me in giving Tamas a huge round the world round of applause. Now, any moment now, Tamas will be joining me on Gather Town for a Q&A session. If you have any burning questions about WebAssembly and JavaScript and how you can make the two of them marry together, please do head over there and join the Q&A session. If you aren't on Gather Town, please do let us know what you plan to do with WebAssembly in your applications in the YouTube chat or on the Twitter chat or wherever it is you're watching along at home. Don't forget to use this hashtag CityJS2021 if you are there. Once again, Tamas, thank you very much for that brilliant talk. Now, for those of you watching along at home, we are about to head into a break, and that means it's time to grab a cup of tea, grab a piece of cake, and head over to the sponsor booths and have a play with what it is that they're offering. We've got tons of great sponsors there with some amazing offers and some brilliant things for you to have a play around. And don't forget, have a wander around Gather Town. See if you can find the secret room. See you soon. Amazing. Firstly, let's give you another round the world round of applause for that fantastic talk. Very useful stuff.
Thank you.
We've had loads of comments coming in saying it was a brilliant talk. Very, very useful. So congratulations on that.
Thank you.
Great talk, amazing talk, superb talk, and fantastic talk, which is high acclaim. So in that talk, you focused on the image part of Cloudinary to some extent, which is fantastic. I think we all kind of have a good idea of what that does now. What other things are in the Cloudinary toolbox that us as developers can reach for to make our life easy? Because it sounds like there's going to be some other amazing bits and bobs in there.
Yeah, so I focused on images, but as I said, Cloudinary is an overall media sort of solution. So you can upload videos and you can do the same sort of transformations and optimizations to your videos that I showed you for your images. And just, I was showing you F-Auto, Q-Auto, so automatic format and automatic quality. That's about maybe 2% of what Cloudinary can do. Things like, in previous workshops and previous talks, I was demonstrating how we do color replace, which is really interesting and important for, like an e-commerce organization. So maybe they have this t-shirt, and the process is they take an image of that. And what if they have this t-shirt in 6 different colors? So then, they would have to take 6 different images. What Cloudinary does, we have this filter that says, hey, take color blue and replace it with red. And it just renders that image for you. So, you can just change these colors sort of on the fly. That's one thing. We do automatic cropping for videos, which is really, really cool. So, sometimes you record a video in landscape mode, but then you want to watch it in portrait. So when it crops, it's not actually focusing on what you want to watch, but it's kind of, to the left or to the right. So Cloudinary has this algorithm, and when you crop a video, it's going to find the most interesting parts of the video. So it's going to keep the crop focus on the main subject at all times, right? I could go on forever, but there's just so much that we do.
Well, I think my video editors
and here's
in the other room are going
sorry,
to be
just one more thing, because sorry, because I did talk about WebAssembly, and Cloudinary also has the option where you can submit your custom functions. So you maybe have a filter that you want to apply to your images, and Cloudinary does not provide that for you. You can just create a WebAssembly file, upload it to Cloudinary, and then Cloudinary is then going to apply that filter to your images on request. I think it's called custom functions in Cloudinary.
That's really, really cool. So we've had a question come in from Dominic. What is your favorite programming language for compiling to WebAssembly? And importantly, why is it that your favorite?
So I only used these two. Actually, I use Rust as well, but I primarily I use C++ and Go. But you need to understand that those two languages are different. So it's going to be dependent on your use case, right? So the C++ project that I used, it used Emscripten, and Emscripten gave me a lot of options when I compile from C++ to WebAssembly, right? As I said, do you want to access the file system? What is the maximum memory I should use? What are the extra libraries you want WebAssembly to access from the C and C++ world? So there's a lot of teeny tiny bits of configuration that you can do. Whereas Go, on the other hand, from C++, I can't access the DOM directly, whereas from Go allows me to access the DOM in the browser directly, but then there's a penalty because you get that JavaScript executable for Go, which brings the entire Go runtime. So that could be a large JavaScript file that you may or may not want to load in your application. I recently read this very good blog post by this developer in the Netherlands, I think, who wanted to it was for one of the largest museum websites, and it's very visual. You can actually do a virtual tour of the museum in your browser, and it was a very, very long article, but a very good read, where this person went through using Emscripten for creating something in WebAssembly, using something else, and at the end he ended up using assembly script with TypeScript to achieve what he wanted for that particular project. So it's always going to be dependent on what you want to write, or what is the tool that you have available at your disposal, and then
all about the use cases.
But I do like C++ and Go equally, so I did enjoy both of them.
Okay, so 2 votes there. I hope that's answered your question, Dominic. We've only got another 60 seconds or so I've got some quick fire questions for you to answer. So one-word answers, please.
Oh, God.
Tabs or spaces?
Spaces.
That was the correct choice. Don't sound so hesitant.
Oh, okay. Good.
TypeScript or JavaScript?
TypeScript.
Front end or back end?
Can I go with both?
Oh, you want to sit in the middle?
Full stack. There you go.
Full stack. Okay,
my company is called Full Stack Training. I have to say full stack.
Okay, on brand. I like it. And finally, apples or bananas?
Apples.
Excellent. Thank you very much for joining us for this Q&A. It's been an absolute pleasure. I'm sure people will be finding you online. And will you be hanging around Gathertown for a little while to chat with some of the attendees?
I'll be back in the afternoon, yes.
Back in the afternoon. Good things come to those who wait, folks.
And tomorrow, of course.
Of course. Excellent. Once again, thank you very much for your time, your effort, your energy, and
thank you for having me.
Informative talk. Everybody else, see you on the stream.